What's up? I'm Vin, and today I want to show how to sketch piecewise functions. So we're going to go through these 5 examples here, and let's get started. So for this question and a few other questions, we're going to use graph paper, and here are some tips to get us through this. So the most common mistake I see with these questions is that when people sketch these piecewise functions, they just draw everything at once. So when they see 3x minus 1, what they think of is they have a negative y-intercept and a positive slope. And then when they see negative 2x plus 1, they have a positive y-intercept and a negative slope, and they treat it like a system of equations, but this is not the way to think about these questions. You want to make sure you're paying very close attention to drawing one piece at a time, make sure your pieces don't overlap, and focus on the intervals because they're going to tell you where everything goes. So the interval here for the first piece is x less than or equal to 0, which corresponds to this part of the graph here, the negative side of the x-axis. So I'm going to be drawing 3x minus 1, but only on this part of the graph here. I'm not going to be going to this part of the graph where x is greater than 0. And depending on how new you are to this, one thing you could do if this is really a confusing process is you could go ahead and make a table of values for each of the pieces. So if I have x is less than or equal to 0, I'm only going to put in x values that are actually less than or equal to 0, like 0, negative 1, negative 2, negative 3, and so on. So if I look here, notice if I plug in x equals 0, I get 3 times 0 minus 1 is negative 1. And if I have 3 times negative 1, that's negative 3, minus 1 is negative 4. And notice my y values are just decreasing by 3. So the next one would be negative 7, and then the next one would be negative 10. But me personally, when I do these questions, I start at this point here. So notice I have x is less than or equal to 0, which tells me this part of my graph is going to be closed circle when it starts. So 0, negative 1. Let me just fix that. 0, negative 1 here is going to start with a closed circle, and then we'll deal with that second piece here, but it's very important to know that this is going to start with the closed circle. And now when I plot my other points, like negative 1, negative 4, I'm going to the left one, down 1, 2, 3, 4. I could just go ahead and plot the rest of the points. But once again, the way I do this, I don't actually spend the time to make a table of values. I start with one point and I use the concept of slope. So if my slope is positive 3, remember, it's very dangerous if you say, oh, that means that I should rise 3 and run 1 unit to the right, because the danger with that is if I go up 1, 2, 3 over 1, notice I'm plotting a point on a part of the graph where this line does not belong. This line should not go past 0. It's only allowed in that highlighted section. So I'm not going to be going up 3 over 1. I'm going to be going down 3 to the left 1. So I go down 1, 2, 3 to the left 1, and that's going to give me the rest of the points that I need here. See, this would be the point negative 2 down 1, 2, 3, 4, 5, 6, 7. So once again, you could go ahead and make a table of values for this, but I personally like to use the concept of slope. And let's see if I could just draw a line. There we go. But this is a sketch. That's why I named the actual question to sketch piecewise functions. That way you don't have to be an artist when you connect these points. So now for the next part of this. So the next piece is when x is greater than 0. And we're only going to be drawing the line negative 2x plus 1 when x is greater than 0. And when x is greater than 0, we're on the positive side of the x-axis. Now, one thing to comment here, when it's x greater than 0, this means that we're going to have an open point at the beginning. So when I make my table of values, this sometimes throws people off, but I could start at 0 because I'm specifying here that this point is going to be open at 0. So technically 0 is not greater than 0, but I'm going to have an open point at x equals 0. And if I plugged in 0, I would have y equals 1. And now values of x that are greater than 0 for this next table, I'd have 1, 2, 3, and so on. And if I plug in 1, I have negative 2 plus 1 is negative 1. And now these are just going to be decreasing by 2. So I'd have negative 3, I would have negative 5, and so on. So if we start this, remember 0, 1, if I plot it with a closed circle, that's bad, because then this is no longer a function. It fails the vertical line test. This has to be open. So this one is open. And now I'm plotting 1, negative 1. I'm plotting 2, negative 3. Or I could use the concept of slope. I'm going to use rise over run. I'm going down 2 units to the right 1 unit. So I'm going down 2 to the right 1 like this. Okay, so we just connect these points here. We draw an arrow, and this is going to be the sketch for g of x. So for the second example here, we have a piecewise function like this. And for examples like this, I highly recommend that you do the algebra to simplify the rational expression. So notice x squared minus x, I could factor out an x, and I'll have x minus 1 left, and my denominator is still x minus 1. And this is for when x is not equal to 1. And then on bottom here we have 2 when x equals 1. And notice I can cancel out the x minus 1s, because even though technically x equals 1 would give us a 0 denominator, the top interval is all values of x except 1. So we can cancel these out without any trouble here. And all we're going to be left with on top is x when x is not equal to 1, and we're left with 2 when x is equal to 1. So anytime you have a piecewise function like this, where there's only one value of x for one part of it, this refers to an actual point. So this is going to be the point 1, 2, and this, what we're left with is y. You can think of this as y equals x. That's a line. So really what this piecewise function is, what I imagine, is that it's the line y equals x, except when x is equal to 1. So at x equals 1, there's going to be a hole in it, and then at that location here, we have the point 1, 2. So that's just like me thinking about this ahead of time. So it's the line y equals x everywhere except x equals 1. So at x equals 1, that's where the hole in my graph is going to be. So I have the line y equals x, except at the point x equals 1. So I'm going to connect these now. And notice here, we have a hole at x equals 1. So the hole is technically at the point 1, 1. And instead of plotting the point 1, 1, we're going to plot the point 1, 2. So this is the point that's coming from the second part of this piecewise function. So this is going to complete our, this will complete our sketch of f of x. So here's a sketch of our piecewise function. So for this next question, we're going to do this without the graph paper, but now we want to sketch the function p of x. And notice for p of x here, where are we going to graph this parabola? We're graphing it when x is less than or equal to 0. So that's going to be this part of the graph here. And then when x is greater than or equal to 1, we're going to be graphing that square root function. So if I just label these points here on the x-axis, so this is at x equals 1, and this is at x equals 0. When x is less than or equal to 0, we're drawing this parabola. And you might be able to draw these really quickly, but when I think of negative x squared plus 1, the first thing that comes to mind is I think of x squared, and then the thought progression goes to negative x squared, which just flips this over the x-axis, and then negative x squared plus 1, the next part of the thought process, just shifts this whole graph up 1 like this. So that's how I'm able to sketch this really quickly in my head. But remember, I am only allowed to graph this top piece here when x is less than or equal to 0. So remember, the most common mistake is people just draw the entire parabola, but we're only drawing it in the yellow section here. So the y-intercept is going to be at 0, 1, and we're including this point because it's x less than or equal to 0. And what we do is we just sketch the part of the parabola that is on this part of the xy plane. Okay, we're only sketching this part here when x is less than or equal to 0. So in a sense, when you're thinking about this, you're kind of ignoring the rest of the graph and only drawing this piece. And now if you think about square root of x minus 1, what I think of for this particular function is I'm using transformation of functions here to help us sketch this. And what we have is square root x, just plain old square root x looks like this. Square root of x square root of x minus 1 moves everything to the right one. So now it's going to start at the point 1, 0, and it's going to open like this. So now I'm going to plot the actual point 1, 0 because x can be greater than or equal to 1. And now we're just going to go ahead and sketch this here. So once again, I got rid of the XY plane. I got rid of the graph paper, I should say, because I just want to use a rough sketch here just to get us an idea of what this thing looks like. And this is the end of the sketch, but one thing to point out here is that p of x is undefined for values of x between 0 and 1. So it's undefined for x values that are strictly between 0 and 1, not including 0 and 1. We can plug in 0 to the top piece and we can plug in 1 to the bottom piece. But for any value, like let's say x equals 1/2, the function will be undefined. So this is going to be our sketch for p of x. So this is a nice question to look at because notice all of these pieces here are just simply constant. However, the first interval is x less than 2. The second interval is just x equals 2. And then the last interval is x greater than 2. So out of all of these, this is just going to be a line. And remember, when you have an equation in the form of, let's say, something like y equals 5, the way I think about this when I see something like y equals 5, I just think of a horizontal line that goes on forever in either direction. And same thing if I have y equals 3, I would just have a line that's going a little bit lower. But the trap here is that the top and the bottom are both going to be lines, but since the interval for the middle part here is only x equals 2, this is going to be the point to -1. So that means when we sketch all this out, we're graphing, in a sense, the line y equals 5, which is going up 1, 2, 3, 4. So let me try counting again. 3, 4, 5 is going up to this height, but it's for values of x that are less than 2. So if we just, once again, code the interval for x less than 2, it's all the values of x to the left of 2. And for something like x greater than 2, we're looking for all values of x to the right of 2 like this. So when we sketch the line y equals 5, I should have labeled it before, we're doing this for values of x less than 2. And notice I put an open circle here because, and let's make that a little bit neater, but I put the open circle because it's strictly x less than 2. If it said x is less than or equal to 2, then I could color this in, but it's x less than 2. And now I'm going to graph the bottom piece next. So when we have the line y equals 3 for x greater than 2, that's going to be down here. So we have an open circle like this, and we're going to the right like this. Okay, because remember, x greater than 2 is heading in this direction here, highlighted in blue. So we could only draw this on this portion of the graph. Remember, the most common mistake is people are just going to draw all these lines at once. And now the last one to consider here is that when x is equal to 2, the y value is going to be equal to -1. So we have 2 holes here. However, the graph we could actually color in here like this. And I'll just label the 2 above like that since we're going to be drawing over that 2. So the actual function value is down here. If I wanted to say, well, what is h of 2? That's going to be equal to -1. So here is a sketch of our piecewise function h of x. So now we'll end with a slightly complicated example, and we'll get rid of the graph paper because remember, these are all just sketches. So what I'm thinking about for a question like this is I think about each of these graphs one by one. So one by one, if I think about y equals -x, that graph is sloping downwards like this. It's going through the origin at a 45-degree angle. And we got y equals x. That's going up like this through the origin, also creating a 45-degree angle. And then sine x is just going to keep that wave pattern. So it starts at 0, 0, and it goes like this. But remember, we're not going to be drawing these all at once. We're going to be drawing them over specific intervals. So when I think about here, I have x is less than 0. That's going to correspond to this part of the x-axis here, the negative side of the x-axis. So if I think about what that means in terms of sketching, I'm only going to be drawing the part of the graph where x is less than 0. So that means I'm going to get rid of this. And what we have here is that this is going to be open at x equals 0. So at x equals 0, this piece is going to be open like this. So our sketch starts off looking like this. But now this is an interesting occurrence here that we have y equals x next between 0 and pi. So if x equals 0 is here and x equals pi is, let's say, over here, that means we're not going to be drawing anything when x is less than 0 or anything when x is greater than pi. So the second piece is going to be a line segment like this between x equals 0 and x equals pi. But notice we have an open circle at the point 0, 0, but then this graph closes the point at 0, 0. So students sometimes get mixed up with this, that if at one part you have it open and at the other part you have it closed, which one is it? But the closed is always going to win, okay? Because that means our function is defined at x equals 0, and when x equals 0, the y value is going to be 0. So now we could go ahead and close this. And remember, at x equals pi, that's when the second piece ends. So let's say for this last one here, I'll color code it. So we drew the first one here, and that's, I'm writing in the pen here. Let's just, or the marker, let me just make this slimmer. So we have the first part we're going to draw in black. Then let's say we draw the next part in blue. Between 0 and pi, it's just going to be a line segment here that's going to go up to y equals pi. So we could go ahead and make another line segment here. I'm sorry, we're going to make a line segment here that's going to stay between these 2 points. And now the last piece is going to be determined by sine of x. So that last piece is for when x is greater than pi. So if we were to highlight this, x greater than pi corresponds to all the values here that are to the right of pi like this. So now we just have to think of the graph. Well, at x equals pi, that's going to be over here when the y value is 0, and it's going to start at this part of the sine curve, and it's going to go like this. But notice it's strictly when x is greater than pi. So that means that at the point pi 0, because once again, this is x sine x, and we're looking at x greater than pi, at x equals pi, y is equal to 0. And if I look at the next few values, like let's say 3 pi over 2, my y value is -1. At 2 pi, my y value goes back to 0. And at, let's say, 5 pi over 2, my y value goes back up to 1. Notice here I'm just counting by pi over 2's. I think of that one as 2 pi over 2, which simplifies to pi. And then I have 2 pi over 2, 3 pi over 2, 4 pi over 2 is equal to 2 pi, and then this would be 5 pi over 2. So I'm starting at pi 0, but this is open. So I have an open circle here. And then 3 pi over 2 would be the next thing that's worth looking at. I'm going down here to -1. And let's say this is not drawn to scale. I'm just doing this to make a point. So we have at 3 pi over 2, we're down at -1. At 2 pi, we're back at 0. And then at 5 pi over 2, if I extend this, we're going up to 1. Let's say that's somewhere over here. Okay, so if I connect this like this is going to complete our sketch. And I'm going to go ahead and put an arrow that this wave is going to continue, because it's when x is greater than pi. This is just going to go on forever. So this is going to be our sketch for the graph of w of x, and we'll just color code it here. So this is a sketch of w of x. Okay, well, this is going to conclude this video on sketching piecewise functions. If this video was helpful, please like and subscribe. It really helps me grow the channel. And if you got any requests, just leave a topic or topics you want me to cover in the comment section below. And thanks for watching.